We are going to be starting today's lesson. Today is Tuesday, September 21st, and this lesson is being recorded. And I expect you to watch the recording on your Blackboard account. I will send you an email as to exactly how to access it on your Blackboard. I will start the lesson with just a review of some of the things that we had done at the last, in our last class, which was writing equations of lines. After I do several examples, I will put an example on the board. I want you to copy that example. And at the end of the lesson, you will have time to complete. There will be a total of 5 or 6 questions throughout the lesson, and I want you to send me those examples together with the work and the answers. I want them emailed to me so that you get credit for doing today's lesson. Okay, so let's start first with a few examples of the type that we were doing the other day. We were talking about writing equations of lines, and let's take an example that looks like this. It says, write an equation of the line that is parallel to the line y equals -2 fifths x plus 1 and passes through the point 5, 2. Now, this actually was an example on a previous midterm. And as you know, our midterms are multiple choice questions. So what I'm going to do is I'm going to not only write the question on the board, which I did, I'm going to give you the different answers that they give. And I'm going to show you how we would go about solving this. So here are my choices. Choice A is 2x minus 5y equals 20. Choice B is 2x plus 5y equals -20. C is 5x plus 2y equals -20. And D, choice D, is 2x plus 5y equals 20. Let's see how we go about doing this example. Now, if you notice, the answers they gave us are not in y equals mx plus b form. So we're first going to have to work out what the answer is going to be in slope-intercept form. And then from that, we're going to have to compare it with the answers that they gave us and see which one works. Now, remember, whenever we want to write the equation of a line, we're doing y equals mx plus b. We are going to have to fill in the slope and the y-intercept. Now, the fact that the lines are parallel tells me that they have the exact same slope. Remember, parallel lines have the same slope. Perpendicular lines, the ones that meet at right angles, have opposite reciprocal slopes. This is parallel. We know that the slope of this line, since this is in the y equals mx plus b form, is -2/5. That's the slope of the line that they gave me. And since I want my line to be parallel, my slope will also have to be negative 2/5. That being the case, what we have to do is replace the m with negative 2/5. So my equation is going to be y equals negative 2/5 m x plus b. We still have to figure out what the b is. And remember, we do this after we put the slope into the equation. We take, if they give us more than 1 point, we can take any point. But in this case, they only gave us 1 point. For the 0.52 is on the line, which means for the x, I'm going to put in 5, and for the y, I'm going to put in 2. So that will give me 2 equals negative 2/5 times 5 plus b. Now here's that situation that we've had several times where we have fractions, and some of the things are fractions and some are not. And that what I said I'd like to do is to take the whole numbers and put them over 1, so it keeps track as to what is in the top, the numerator, and what's in the bottom, the denominator. So this becomes simplifying 2 over 1. Now, the first thing I have to do is multiply the negative 2 over 5 times the 5 over 1. Now, in this case, there is a numerator denominator that can be canceled out. So this becomes negative 2 over 1 plus b over 1. And then to get the b alone, I'm going to have to add 2 over 1 to both sides, which gives me my b. Let's just move it over here. 4 over 1 equals b over 1, or more simply, the b equals 4. So the hardest part usually is if there are fractions and you have to work out the fractions. But again, just do it simply. Again, you are entitled to use a calculator. So you can use your calculator. Of course, then your final answer for our equation, the one that we're doing here, then my answer becomes, let's put it over here, y equals negative 2/5 x plus 4. Now, the problem is that none of these are this answer. So there are two things I could do. I could either take the answer and try to get it into this format, take the answer that's in the y equals mx plus b format and put it into the standard format. Or if you prefer, you could take each of these answers and try and put those in the y equals mx plus b form. Usually I find that easier. These answers that are in standard form are already without fractions. So if I take, for example, a, which is 2x minus 5y equals 20, and I put that in the y equals mx plus b form, I'd have to subtract 2x from both sides. That will give me negative 5y equals negative 2x plus 20. And then I'd have to divide everything by negative 5. And when I do that, I get y equals, well, negative over negative is positive, 2/5 x. And 20 divided by negative 5 is negative 4. And if I compare it, the numbers are the same, but the signs are wrong. This has a negative 2/5, and this has a positive 2/5. So obviously, this is not the right choice. So now, let's look at some of the other choices. Of course, I'm going to have to erase some of the things that I have here. So I'm going to erase this, which is the original question, and just leave the answer that I got. Again, that is the basic problem with a multiple choice question, is the fact that after you do the problem, the choices might not be exactly what you're looking for. So let's take choice B. Let's look at choice B. Choice B is 2x plus 5y equals negative 20. Okay, I'm going to again want to bring the x's to the other side, so that's minus 2x. So it gives me 5y equals negative 2x minus 20. And when I divide everything by 5, I get this b in y equals mx plus b form to be equal to negative 2/5 x minus 4. And if I compare it with the answer I'm looking for, I'm almost there, except instead of the negative 2/5 for the x is correct, but then I need a negative, I don't want a negative 4, I want a positive 4. And if I compare that, that must mean I'm looking at choice D, because choice D is exactly the same as choice B, except instead of having a negative 20, I have a positive 20, and that's what I want. I need a positive 20 so that when I divide it by 5, it'll give me positive 4. So my correct answer is choice D. Alternate method. Here we started with the answers and got the answer in the y equals mx plus b form so we could compare it. The other method we could have done is to take the answer that I got, which was negative y equals negative 2/5 x plus 4, and find put everything over 1. That's not a fraction. And multiply everything. Remember I said one of the ways of dealing with equations with fractions is to get rid of the fractions by multiplying by the common denominator. The denominators here are 1, 5, and 1. Obviously, the common denominator, the LCD, is 5. 5 can divide into 5, and 1 can divide into 5. We take that denominator, 5, put it over 1, and multiply each term by that common denominator. So 5 over 1 times, so we're getting 5 over 1 times y over 1, I'm distributing, equals 5 over 1 times negative 2 over 5x plus 5 over 1 times 4 over 1. Now over here, remember when the denominators turn out to be 1, I don't even have to put them in. So this is 5, there's nothing to cancel out. I have 5 times y over 1, which is just 5y. Over here, the 5 in the numerator cancels with the 5 in the denominator. And I'm left with 1 times negative 2. So that's negative 2x, because the bottom again is 1. And finally, here nothing cancels out, so I do 5 times 4, which is 20 over 1, which is just 20. And if I want it in the standard format, I need to get the x and the y on the same side. So I add 2x to both sides, which gives me my equation 2x plus 5y equals 20, which again is exactly choice D. So this doesn't happen very often. When we work our questions out, we'll get an answer in what we call the slope intercept or y equals mx plus b format. If they ever use the term standard format, that means you want the x's, the y's on one side, a number on the other side. You don't want any fractions of them. So you can either convert your answers to slope-intercept form or vice versa. You could take your answer and convert it to standard form, whichever way you like doing that better. But you have to somehow match up. The answer we got did not match up with the setup, the format that we're using for the answers. So as again, this is it. Sometimes we say it's easier because when questions are multiple choice, but we have to keep in mind that when we have multiple choice, we have to be able to make the answers match up. Okay. Let's do one more example of this type, and then I'm going to put one or two questions on the board for you to do after we finish class. Okay, so I'm going to erase this and we're going to do another example. Again, this is a review of what we had done on Tuesday, on the 14th, a week ago. Again, I'm going to take another example from a midterm, because I want you to get an idea that these are the type of questions you could come across. I'm giving you 2 points. One, -6, and -1, 2. And the question is, find the equation of the line through the 2 points. Remember, again, we're writing equations of lines. In this case, we're told that we have 2 points on the line. Here is what we're going to call our x1, y1. And this is going to be our x2, y2. And we were going to want to write the equation. So you have to read the question carefully, because sometimes they ask you find the equation, but sometimes they just say find the slope. When they say find the equation, they want you to get something in the y equals mx plus b form, which means there are 2 things you have to figure out. You have to figure out the slope, the m, and you have to figure out the y-intercept, the b. And remember, we always go to finding the slope first. Let's find the slope. Now, remember how the formula for the slope. This is something you must know. It's y2 minus y1 over x2 minus x1, which gives me 2, my y2, minus -6 over -1 minus 1. Now you have to be careful. Remember, when you have this double negative and negative and negative, that turns out to be a positive. So this actually becomes 2 plus 6, which is 8. and the denominator is -1 minus 1. That is -2. Be very careful. The biggest mistakes that are made here is the fact that people are getting their adding and subtracting wrong. If you're not sure, put it in your calculator. -1 minus 1 gives you -2. And 8 divided by -2 gives you -4. The slope of this line is -4. So I know my equation is going to be y equals -4x plus b. The next thing we have to do is figure out the b. What is the y-intercept? And we can do that by taking either one of the points. I can take the x being 1 when the y is -6, or I can take with the x to be -1 when the y is 2. Always make sure you keep them paired up. Let's say I use the first point. I am going to then replace the x by 1, and I'm going to replace the y by -6 to give me an equation. -6 equals -4 times 1 plus b. Of course, I always multiply the m and the x together first. That gives me -4. So I have -6 equals -4 plus b. And to find out what the b is, I'm going to add 4 to both sides. And that gives me -6 plus 4 is -2. The 4's cancel out, is b. So my equation in the end comes out to be, here's my answer. Y equals -4x minus 2. And if we're asked, what is the y-intercept? Then we would say the y-intercept is -2. If we're asked what is the slope, we'd say the slope is -4. If we're asked for the equation of the equation of the line is y equals -4x minus 2. What if I had asked the question, what is the slope? I now know my equation of my line is y equals -4x minus 2. What if I asked you, what is the slope of a line that's perpendicular to this line? Well, I know the slope over here is -4. We know our m of my original, the line that we're looking for, is -4. So the slope of the perpendicular line will have to be the opposite reciprocal of the -4. Well, -4 is really -4 over 1. So the perpendicular line slope, which is right over here, would have to be +1 over 4. Flip the fraction, switch its sign. So if I ask you what's the slope of a perpendicular line, you'd say 1 over 4 is the slope of the perpendicular. Okay, I'm now going to write 2 problems on the board. Again, You are to copy down these problems, and at the end of the lesson, you are to do those problems and send them in. I would, if you get help with them, it is fine, I don't mind, as long as you, when you send in the examples, I want you to write, I watched the video and I copied the examples, and these are the examples I did. I want you to specifically tell me in the email that you actually watched the video. Okay, so now I'm going to erase this and put 2 problems on the board and give you a few minutes to copy them. Okay, so here's the first example. Find the equation of the line through points 1, -6, and 4, 0. And you can write the equation in any format that you want to. I would assume that you will do it in the y equals mx plus b form, but if you want to put it in a different format, that is fine as well. That's question number 1. Here's question number 2. I want you again to find the equation of a line which is perpendicular to 3y plus x equals 7, and passes through the point -2, 5. Okay, I'm giving you a few minutes to copy these questions. Okay, I'm going to be erasing this in a couple of minutes. If you haven't finished copying it, then you can just pause this and copy it and then start your video again. Okay, so we're now going to do one more type of review, and that is what happens if I have a question like this. Okay, so this is, we're now going on to more review. Just suppose I give you a question like this. This is, again, we did this on last Tuesday, but I just want to review it. What if I give you a question like, I want to find the equation of a line, that of a vertical line that passes through the point for -5. And I also want you to state what is the slope of that line. Okay, so we have a vertical line that's going through the point 4, -5. We want to write the equation of the line and also give the slope of the line. So let's just do a sketch of this. Here's the point 4, -5. It's 4 to the right and 5 down. This point. And this is the vertical line. Remember, the word vertical means straight up and down. Let's reminder also that when we have a vertical line, its equation is x equals a number. Vertical lines don't have any y in their equation. They just have x equal a number. Horizontal lines don't have any x's in their equation, they just have a y. So they're really, as long as you remember them, they're really the easier equations to write. In this case, since I know x equals a number, I just look at the x value. It must be that the equation of this line is x equals 4. If I asked you what the slope of this line is, the slope is undefined. It doesn't exist. You can either use the term undefined, or you could write D and E. Does not exist. There is no slope. It's the only type of line that doesn't have a slope. Lines that are straight up and down, vertical lines, lines that are perpendicular to the x-axis. Those are vertical lines, do not have any slope, and their equation is x equals whatever the x value of any point on that line is. Okay, just wanted to remind you of this. It was something we had talked about the other day. So now I want to go on to a topic that we have not talked about yet, and that is something called functions. Okay, so I'm going to erase this and we've been dealing with these equations of lines. And in these equations, we've been dealing with two variables. For example, we might have had y equals 3x minus 1. Notice only when we have vertical lines or horizontal lines do we only have one variable. In most lines, all of the slant lines, when we write the equation, we have two letters. We have an x and a y. And it's not as if you can possibly solve for this, because I can't say solve the equation. I can only solve an equation that has only one variable. What I can do is I could say, okay, if I pick x to be equal to 7, what will y equal? I could do something like that. I can assign a value to the x and find the corresponding value for y. And we do it by simply replacing the x by 7, and we'll get y equals 3 times 7 minus 5, which is 21 minus 5, which is 16. In other words, when the x, we pick the x to be 7, the y is going to have to be 16. In these two variables, we give the name to the x variable as the independent variable, and the y is what's called the dependent variable. What does that mean? It means that I am free to take any value I want for x. X could be 7, x could be negative 100, x could be the square root of 72 if you want some strange number. But once you pick that value for x, then the y is determined. Then your y can't be anything. Your y, in this case, if I pick the x to be 7, the only value y could be is 16. That's why y is the dependent variable. It depends on the value of the x. We sometimes write this by saying that the point 7 comma 16 is a point on this line. We know it's a linear equation because there are no x squared or y squared. And to say that this is a point on the graph of this line is telling me that these two values match. When x is 7, the y will be 16. Now, to really pinpoint or indicate the importance of this relationship is what we notice is that if I give you one value for x, you're going to get exactly one value for y. 1x, I pick any 1x, the value for y is going to be set. There's only going to be one answer to y. Whenever that happens, we have something that's called a function. A function is a kind of equation with x's and y's that when you put in your value that you pick for x, there's only going to be one answer for y. We're going to see later on in the term, not all equations work that way. Sometimes you get more than one answer. But with a function, the type of equation that this is, it must happen that for every x, you'll get exactly one y. And actually, that's what we want when we're dealing mostly in mathematics. Mathematics is called the exact science. What does that mean, it's the exact science? It means that each question has one answer. Now, you're going to see later on, there are going to be some questions that have more than one answer. Well, we even had a case already. We had an absolute value equation that ended up with two answers. Sometimes when we have absolute, that might not be an example that is a function. A function when you have only one answer. And to emphasize that the type of equation that we're dealing with is a function, we sometimes use something that's called functional notation. Because these are the type of equations that we really prefer using. It's nice to know ahead of time that what we have is that type of equation. And the functional equation notation looks something like this. Instead of y, you replace the y with a letter from the middle of the alphabet, something like G or F, usually it's F, parentheses X. Now this symbol, F parentheses X, is read F of X to indicate it's a function of X. F of X. That means instead of writing y equals 3x minus 5, we're going to write f of x equals 3x minus 5. In other words, this f of x is just another name for y. You see the parallel. Obviously, you have to write your equation y equals first. You can't have an f of x in the middle of the equation. It always has to be the start of the equation. So if you had an equation where the x's and y's are all mixed up, the first thing you would do is you would put the y equals, you would solve for y, and then you could replace the y with this new symbol f of x. It's like calling somebody whose name is Kathleen, but sometimes we call her Kathy. Kathleen and Kathy are the same person. Kathleen and Kathy are just different names for that person. Same thing over here. Y and f of x are exactly the same thing. In other words, we could say that y equals f of x. So the question is, why are we introducing this new symbol? Well, first of all, this new symbol is very important when you learn calculus. I mean, you're not doing up to calculus yet, but a lot of you will be going into calculus, and you'll see this functional notation will be used a lot. But even for us, it has some significance. First of all, as soon as I use this f of x, this functional notation, I'm right away telling you that I'm dealing with a function. I can't use functional notation on something that's not a function. So I'm right away telling you that you have a situation, an equation, where if you give an answer for x, there's only going to be one answer for y. That's very good to know, because sometimes there's situations where you could get two answers. How are you going to know whether you should be getting two answers or not? When I use f of x, I know I can't get two answers. I know I have to get exactly one answer. There is another advantage to that, and that's in using the functional notation as well. Instead, again, we're going to be calling our function f of x. So if I write f of x equals 3x minus 5, then I could say find, for example, f of 7. In other words, I can take this x and replace it by a number. And what that will tell me to do is that wherever I have an x in my other side of my equation, I replace the x by 7. In other words, this will be 3 times 7 minus 5, which again is 21 minus 5, which is 16. Instead of having to write this whole example, if you pick x to be 7, what will y be? All you have to do is say, find f of 7 in one little symbol. It's giving you this whole long question. It's much more efficient way to write it. So not only does when we use this f of x, does it tell us that we're dealing with is a function, it's also an easy symbol to use. And sometimes you'll see in one problem, two different equations. Y equals 3x minus 5 and y equals x squared, let's say. Two different equations. And it's very hard to keep track of which equation are you dealing with. With this functional notation, you can call one function, let's say f, and another function g, and therefore you'll be able to differentiate between which equation you're talking about. So what do you need to know specifically? Well, number one, you have to know that you're getting one answer. And number two, you have the most important thing that you have to know for this is how to use this functional notation. So let's take some examples and I'll show you how to do it. And notice, it doesn't have to always be a linear equation. It could be any type of equation. I'm going to erase this and I'm going to give you let's say give you, let's not use f of x, let's use g of x. Remember, g of x, any letter, basically any letter like F, G, or H, those are the basic letters that are used for functions, with a parentheses and either a number next to it or a letter next to it is functional notation. Suppose I tell you that g of x is equal to x minus 9 squared, and I want you to find g of 4. Now, is g of x a function? Obviously, we're using functional notations. I don't have to even think about if it's a function or not. It has to be a function. We only use this in situations where we have functions, where for each x we get one y. When they're asking me to find g of 4, what they're asking, I'm being asked to do is to replace in my original expression, wherever I see an x, replace it with 4. So that's going to be parentheses 4 minus 9 squared. All I have to do is work this out. So 4 minus 9 is negative 5. So I have to do negative 5 squared. Remember, you do what's inside the parentheses first. And negative 5 squared means negative 5 times negative 5. So my answer is 25. Okay, there is one other thing we could do. Suppose I gave you something like this. Suppose I tell you that f of x is equal to 3x plus 2. And I want you to find f of a. Even though a is not a number that I know, it represents a number, and all it means is to go to your original equation, your original function, and wherever you see an x on the second side, you're replacing this x by a. On the other side, you have to replace those x's by a as well. So that'll give you 3a plus 2. Notice you can't simplify this any further because these are not like terms, but your f of a is 3a plus 2. What if I ask you to find f of b plus 3? What did I ask you to do that? What is that telling you to do? That's telling you to go to your original function and replace the x that you have, this x over here, let's put a circle around it. I'm replacing that by b plus 3. In other words, it'll be 3. Now, I have to put a parentheses around it because the x is more than one term. So it's 3 times b plus 3. Plus 2. Of course, if we can simplify, we do. We'll use our distributive property and we'll get 3b plus 9 plus 2. These two numbers are like terms. So in simplest form, that answer becomes 3b plus 11. So this functional notation can be pretty handy and it can help us. Again, it's going to be very important for us when we go on to pre-calculus and calculus. I'm going to do one more with you together, and then I'm going to put, this is where we're going to afterwards go, I'm going to put in 3 more problems on the board of the type of things that we were just talking about now, and then I will give you time to complete your assignments and to email them in. Again, if you can email this to me, obviously before our next class, which is going to be on Thursday, the 23rd. Okay. So let's do one more problem together. Suppose I give you that f of x is equal to, again, this is, I'm taking this off, a lot of these questions are taking right off of the old midterms, so you get an idea of what type of questions you might encounter. Suppose f of x is equal to 2x squared minus 5x plus 4. And I ask you to find f of 5. Find f of 5. So that means, in this case, what we're going to do is, in our equation, wherever we have an x, we're going to put a 5. So it's going to be 2 times 5 squared. I usually replace the x's with a parentheses and fill in the parentheses with the number or value over here. I did it over there. I replaced the x over there with a parentheses and filled it in with b plus 3. Over here, I'm replacing this x with a parentheses and I'm filling in with 5. So this is 2 times 5 squared minus 5 times 5. Remember, we're replacing x with 5 plus 4. Now, you can either stick this straight into your calculator or you could work it out. Don't forget the order of operations. You first have to do the square first. So this is 5 squared is 25. And when I multiply the 2 times the 25, this first term becomes 50. Minus 5 times 5 is minus 25. So we're subtracting 25 plus 4. And 50 minus 25 is 25. 25 plus 4 is 29. So my answer for f of 5 equals 29. So that's how you would do one of these functional notation problems. Okay, this basically completes chapter 2. I'm going to be starting with chapter 3 next time. And I will probably be telling you when I'm assigning our first test because we have finished 2 chapters, but I want to do that when I'm meeting with you in person. So we will talk about that on Thursday. Okay, here are the 2 questions that I do, the last 3 questions that I want you to do. Remember, I already gave you 2 questions. Here are 3 more questions. Okay, here's question number 3 is find the equation of a line that is parallel to the x-axis and having a y-intercept of 6. That's question number 3. Question number 4. If g of x is equal to 2x squared minus 5x plus 3, find g of -2. And question number 5, so there will have been a total of 5 questions on this exam, not on this, of these examples. This is not an exam, it's basically homework. If G, if h of x is equal to 7x minus 5, find h of 3a plus 1. Obviously, this final answer will be an answer in terms of a. This answer will be a specific number because this is a specific number that we're picking for an x. Over here, we're picking for an x to be an algebraic expression. So my answer will have to be in terms of a. Okay, I'm giving you a few minutes to copy that. And again, email me. I'm sure you all know my email address. You can either email me from the Blackboard account, or you can email me directly. P. Weinberger at mec.cuny.edu. Again, this should have not only the answers, but the work as well. I'd like to see your work as well. There should be a total of 5 questions, 2 that I gave you before, and these 3 now. Okay, again, I'm going to now end the session, and of course, you can always go back, or you can pause it if you want to look at something again. Have a good day.